I'll be explaining the solutions for task 1. Based on figure 1, we'll be using nodal analysis to derive the value for V1 and V2. At node V1, the equation derived is V1 over 2 plus V1 minus V2 over 4 plus V1 minus V2 plus 4 over 3 equals to 2. Next, I have equalized the denominator so I can get the first equation, which is 13V1 minus V2 equals to 8. At node V2, the equation that I've gotten is V1 minus V2 plus 4 over 3 plus V1 minus V2 over 4 plus 4 equals to V2 over 3. After equalizing the denominator, I've derived the second equation, which is 7V1 minus 11V2 equals to negative 64. Using the substitution method, I've gotten the value for V1, which is equals to 5.7 volt, and V2, which is equals to 9.44 volt. From figure 2, we have 4 loops. Using mesh analysis, I've derived 4 equations. The first equation is 8i1 minus 4i2 minus 4i3 equals to negative 2. The second equation is negative 4i1 plus 8i2 minus 4i4 equals to negative 10. The third equation is negative 4i1 plus 8i3 minus 4i4 equals to 8. And lastly, the last equation is negative 4i2 minus 4i3 plus 8i4 equals to negative 2. From these 4 equations, we have derived the value for a 4 times 4 matrix. To solve this and calculate the value for I1, I2, I3, and I4, I've used Cramer's rule. By using Cramer's rule, I have gotten the value for the determinant of I, which is equals to 3712. The determinant for I1 is equals to 64. The determinant value for I2 is equals to 1272. The determinant value for I3 is equals to 640. Lastly, the value for determinant I4 is equals to 4800. To calculate the value of current, I've used the formula, which is determinant for I1 over determinant of I. So for the first current, I've gotten 64 over 3712, which is equals to 0.02 ampere. For the second I2, I've gotten 1272 over 3712, which is equals to 0.34 ampere. For I3, the equation is 640 over 3712, which is equals to 0.17 ampere. And lastly, the value for I4 is equals to 4800 over 3712 equals to 1.3 ampere. Thank you, that is all for my part.
So today we are here to solve this complex circuit equation. That we are solving here is find V node by simplifying the circuit using only source transformation to a single mesh circuit. Given current is 2.5 ampere. First of all, we are transforming this 2 ampere into voltage source, from current source into voltage source, and this 16 ohm will be series with these 2 voltages. First, transform 2 ampere current source into voltage source. This is the formula of transformation. Vs is equal Is times R, equal 2 times 16. So Vs is equal to 32 volt. Also 6 ohm and 3 ohm are in parallel, will be 2 ohm. Our circuit will be like this. So that this 32 voltage and this 8 voltage are in series. So we are combined together. And also this 16 ohm and this 20 ohm are in series. So we we are combining together. So 32 voltage and 8 voltage are in series. V is equal to 32 plus minus 8. V is 24 volt, and also this 16 ohm and 20 ohm are in series, so will be 36. We'll be adding 36 ohm, and also 2 ohm and 10 ohm are in series, and also are in parallel with 3 ampere, so will be 12 ohm. So our circuit will be like that. After that, transform 24 voltage source into current source. Is is equal Vs divided by R. That's equal to 24 volt divided by 36 ohm. That will be 0.66 ampere. So we put here the current. After that, this 36 for a series. So after that, when we transform this into current source, this will be in parallel. Our circuit will be like that. So 36 volt, 36 ohm are in parallel with 12 ohm. So we will combine together. So it will be 9 ohm. This will be 9 ohm. Now we have two current source. Size that 0.66 ampere is parallel with 9 ohm and 3 ampere is parallel with 12 ohm. Transform both of them from current source to voltage source to get a single mesh circuit. V1 is equal Is times R. 0.66 times 9 ohm. V1 will be 6 volt. And V2 is equal Is times R. That's equal 3 ampere times 12 ohm. V2 also will be 36 volt. So now we have 2 voltage sources and 3 resistors. So we will combine these 2 voltage sources and we will combine these 2 resistors, because 12 are in series with 7 ohm. So 12 is in series with 7 ohm. That will be 19 ohm. And also 6 volt is in series with 36 volt. Now we get a single mesh circuit. Last step, we will apply KVL. First we put I in here. We are starting here minus 42 volt plus 9I plus this 19I minus V node is equal to 0. That's our equation. Put V node in the other side. So V node is equal minus 42 plus 28I. Since I is 2.5 ampere, so we put position for I that value. V node is equal minus 42 plus 28 times 2.5. So it will be minus 42 plus 70. Last get V node as equal 28 volt. That's all for me. Thank you, doctor.
Simulation for the task 1. In this simulation, we use 6 resistors that have the value 1 ohm, 2 ohm, 4 ohm, 5 ohm, 2 ohm, and 3 ohm. In this simulation also we have 2 current supply that have value 2 ampere and 4 ampere. In this simulation, we want to find the value for V1 and V2. So if we run this simulation, we will get the value for V1 and V2, which is the value for V1 is 1.9998 E plus 008, and the value for V2 is negative 2.99925 E plus 008. Next one is for figure 2. In this simulation, we use 8 resistors that have the value 2 ohm, 2 ohm, 4 ohm, 4 ohm, 4 ohm, 4 ohm, 2 ohm, and another 2 ohm. If the figure 1, we use the current supply, while for figure 2, we use the voltage supply, which is 10 volt and 8 volt. We also know that figure 2 use mesh analysis based on the equation. So to find the I1, I2, I3 and I4, we need to use the ammeter. When we using the ammeter, we need to make sure the ammeter in series circuit. If we running this simulation, we will get the value for I1, I2, I3 and I4. I1, which is 0 ampere, I2 is negative 1 ampere, I3 is negative 1 ampere and I4 is 0 ampere.